Hi guys, this is Prompt Engineer, and in this video we are going to continue our podcast Mojo Let's Learn that we have started a couple of days ago on understanding Mojo and getting started with Mojo. So in the last two videos we looked at the let and var declarations and the hello Mojo, and in the last video we looked at structs and classes. So once again, Mojo is a new programming language for all the AI developers. It is a revolution and it will be very essential that you learn this programming language. Mojo claims to be about 35,000 times faster than Python, but to test it out, we don't have the compilers yet, but you can request for a playground. And I was lucky enough to get access to the Mojo playground. So this is the playground that we received. It has different files, couple of files, and we are going to look at hellomojo.ipynb. This is how we get started. This is the hello mojo print statement. We already seen this. The let and var declarations. This is immutable and var is mutable. And the struct types, which can be compared to classes, but in a more stricter form. In today's video, we are going to look at strong type checking. Strong type checking refers to a mechanism where the types of variables and values are checked at compile time itself, ensuring that operations and assignments are performed only on compilation types. So if you look at this example, here we have defined a struct called myPair, which represents a pair of values. And in this function, we define a function called pairTest, which will output a Boolean type data. Now let P is equal to myPair of 1 and 2. So the myPair we have already seen creates a pair of data using the first and the second parameters inputs. So if we let P is equal to myPair of 1 and 2, when we say let declaration, it means that it's an immutable type of declaration and we cannot change the let. Now if we run this, there is no such error. But if we uncomment this line and we try to compare P with 4, then we get this. Now this error occurred because the comparison operator here defined in the myPair struct expects both the operands to be of type myPair. Since 4 cannot be converted to myPair, the compiler detects the type mismatch and flags it as an error even before the program runs. This is huge. Now some of the benefits that goes along with the strong type checking in Mojo is that firstly, strong type checking allows us to catch potential errors at compile time itself. Secondly, strong type checking enhances the reliability and stability of our programs. Additionally, strong type checking improves code readability and maintainability. Lastly, strong type checking facilitates code refactoring and evolution. Now, having completed the type checking, let's move on to the overloaded functions and methods. Now, just like in any other popular language such as C++, Java, Swift, Mojo allows you to define multiple functions with the same name but different argument list. This powerful feature enables you to ensure type safety while designing your programs. In this example, we have a struct called complex, representing a complex number. As you can see, we have two init methods in this complex structure or struct. The first method takes a single argument x of type floating point 32-bit and constructs a complex number with a given real component. The second method takes two arguments r and I, both of type f32, and constructs a complex number with the given real and imaginary components. Now, depending on the arguments passed during object initialization, the appropriate init method will be called or invoked automatically by Mojo. This allows you to initialize complex objects using different argument combination, thereby ensuring type safety and providing flexibility. Now, let's run this and let's see the utilization of this. Now here we have defined complex 1 using a let declaration, which is complex 1 is equal to complex of 5, which means the code Mojo is going to use this piece of code here. And when we say let complex 2 is equal to complex of 3 and 10, we're declaring two parameters here. So Mojo is going to use this. So here we print complex 1 of real and complex 1 of imaginary. We print complex 2 real, complex 2 imaginary. Here we see that it has given the desired output. It is important to note that Mojo does not support overloading solely based on results type. Additionally, Mojo's type inference system doesn't rely on result type or contextual type information, keeping things simple, fast, and predictable. This design choice ensures that Mojo's type checker remains efficient and straightforward, preventing complex error scenarios. Now with Mojo, you'll never encounter an expression too complex error, as its type checker is intentionally designed to be simple and fast. Now that's a wrap on overloaded functions and methods and strong type checking in Mojo. In the next video, we are going to learn about function types, how we define a function, how it is different from DEF, and the copy init and the move init spatial methods, and importing of Python modules in Mojo. So that's it. This is the third video in the series of Mojo Let's Learn. Please follow this series and please follow other videos on my channel. If you like this video and like this style of presentation, please like the video, share it with your friends. Please consider subscribing to my channel, as that would help me boost my morale to create such interesting and new videos for you. Signing off, this is Prompt Engineer. Have a nice day.